today we will come to the next portion, the law of Archimedes principle. Okay, verification of Archimedes principle of the law. Okay, and also the upthrust and the buoyant force. Okay, as already we have discussed about the upthrust or the buoyant force. Okay, and before we come to that, let us come to the apparent weight. Apparent weight means the loss in weight of a body when it is immersed in a liquid. As you know that when a body is immersed in a liquid, the body starts losing its weight. That means its weight decreases when the body is immersed in a liquid. Okay, and that loss in weight of a body, we call it as apparent weight. Apparent means not real, that means it is not actual weight. And already before you immerse the body in water, you find the body in air. First, weigh the body in air. Okay. Then after finding the weight of the body, you note it down. Note that weight of a body in air. Then tie a body with a thread and immerse inside the water. And when it completely immersed in the water, okay, you find that the weight of that body, when immersed in the water, it decreases. And that decrease in the weight can be calculated with the help of a device, with an instrument called the spring balance. Okay, so that we call it as an apparent weight. Now, as you know that it is very easy to lift a stone inside water. Okay, now why it is very easy to lift a stone inside the water is as the stone is inside the water, okay, there is a decrease in its weight. And that decrease in the weight, we call it as the apparent weight, and that is due to the upthrust which is provided by the water to the stone. Okay, but when that stone is moved away from the water, or if you lift it just away from the water, you find it heavy. So as you know that it is easy to lift a body inside the water than in air. So what makes a body to lift? What makes a body to lift in water easy or lighter? Some force is acting in the body when it is immersed in a liquid, okay, and that force makes the body to decrease in the weight inside the water, and that force we call it as an upthrust or the buoyant force. Okay, so related with that, let us come to the Archimedes principle. Now, what is Archimedes principle is? Now, Archimedes principle states that when a body is partly or wholly, either partly means partly immersed in liquid or completely immersed in liquid, okay? When a body is partly or wholly immersed in liquid, the body will experience the upthrust. The body will experience upthrust which is equal to the weight of the liquid displaced by it. Okay, so this is Archimedes, the law of Archimedes principle. Okay, which says that when a body is partly or wholly immersed in a liquid, the body will experience upthrust which is equal to the weight of the liquid displaced by it. Okay, now for that, let us consider a spring balance. Okay, let us consider two cylinders A and B. Now A is a hollow cylinder. Hollow means like a beaker, like you can take a glass. Glass is a cylinder. It is a form of a cylinder. Okay, like a glass, you take a hollow, and glass is a hollow cylinder. Okay, it's like a hollow, this kind of cylinder. Okay, hollow cylinder. So A you take a hollow cylinder, and other you take a solid cylinder. Solid cylinder means you take some metal. Okay, which is entirely a solid metal, which is in the shape of a cylinder. So two cylinders you take it. Cylinder A and B. So find their weight. Find both their weight in air. Then after that, what you do is that on the left side of the tank of a spring balance, okay, you place a beaker, and that beaker is filled with water. Okay. Then after that, what you do is that now slowly what will happen? This solid cylinder you immersed inside a beaker filled with water, And the care should be taken that the solid cylinder should not touch the side of the beaker. It should be straight. Okay, it should be dipped inside the water. So when it is dipped and the hollow, and it is also fixed with the hollow cylinder. Hollow cylinder is also top here. Okay, so both hollow cylinder as well as the solid cylinder. But the solid cylinder is immersed inside the water. So now what happens is that when the solid cylinder is immersed inside the water, what you will observe is that now the left side of a pan, that is the spring balance, it rises up. It rises up. So that means why it rises up means because when it enters, when these solid cylinders, when it enters inside the water or immersed in the water, this water will provide upthrust to the solid cylinder, which causes the apparent loss in weight of the solid cylinder. So therefore, the pan of that spring balance, it moves up. Okay. Now what you do is that now in this hollow cylinder also you start, hollow cylinder means it is empty inside. Okay. In the hollow cylinder also you start filling the water. Okay. You start filling the water. Now before that, the hollow cylinder is empty. Okay. Only this the solid cylinder is inside the water. But what happens when you immerse inside the water here? The pan of the spring balance, it rises up, which shows the apparent loss in weight. Okay. Now here, afterwards what you do now, on this hollow cylinder also you fill with water. And you fill the water up to a brim. Up to a brim means up to a level so that the water should not get overflow. Okay. Now once you fill the water in this hollow cylinder also, now what we'll observe is that slowly the level of this pan, which has been raised up, now it becomes equal. That means it balanced now. It becomes down and it remains balanced now. Okay. That means before it was rising up because of the loss in weight. Now when you start filling the water in the hollow cylinder also, what will happen here? Now slowly what you will observe? Now the raised pan will come down and finally it get balanced now. Okay, now from here what it denotes is that the weight of the displaced liquid is equal. Okay, the weight of the displaced liquid. That means displaced liquid means whatever the liquid which has been displaced by this solid cylinder in a beaker, this liquid which has been displaced by the solid cylinder is equal to the weight of the liquid which are present in a hollow cylinder A. Okay, again I repeat here. Now why they get balanced is that now this solid cylinder, when you put it inside the beaker, this solid cylinder will occupy space in the water, and the water before this solid cylinder immersing inside that beaker, it is occupied by water. Okay, now when you place that solid cylinder, now this place of water will be occupied by the solid cylinder. Okay, now this solid cylinder will displace the water, and whatever the water displaced by the solid cylinder is equal to the weight of the hollow cylinder. So we say that the weight of the body is equal to the weight of the liquid displaced, which verifies the Archimedes principle. Okay, now other verification is also there. Okay, now other verification is that now there is a spring balance here. Okay, and there is a stone. The stone is immersed in the water, and this is the displacement can. Okay, displacement can means a beaker. Okay, having a spout. Okay, spout is there. Now first thing what you do is that now you fill the beaker, the displacement can with water. Okay, and you keep on filling the water so that the water gets overflowed. Okay, and the water keeps on over, and you keep just below the spout you keep a beaker, and the overflowed water will be contained in the beaker, will be collected in the beaker. Okay, and you keep the beaker unless all the water from the beaker, from the spout, it drips out. Okay, and after dripping, after all the water will come out, okay, if the water will stop flowing from the spout, remove this beaker. Then bring the empty beaker, which is okay, which is dried in here and weighted in here. You will find the weight of that beaker in here, dried in the air, as well as you will find the weight of that empty beaker. Now empty beaker you place it here. Okay. Now what you do is that you bring a stone here. You bring a stone and you you tie the stone with a hook of a spring balance, and the mark which has been given, the calibration we call it, the calibration of a spring balance is given in a gram force. Okay, because you are finding the weight. Okay, so the unit is given in gram force here. Okay, now what you do is that slowly what will happen? Now immerse the stone inside the water. Okay, immerse the stone inside the water. Once you immerse the stone inside the water, okay, find the stone in air as well as now you find the stone in a water also. Okay, first you find the weight of a stone in air, weight of the beaker in air. Okay, then after that what you do? Slowly you put the stone inside the beaker. So once you put a stone inside a beaker, that is the displacement can, the water will come out from the spout and start collecting in a beaker. That means the water has been displaced now. Okay, now why the water has been displaced? Now whatever the water which is present in this displacement can, when the stone is immersed here, now that stone will occupy a space, and where the water has to go, the water has to come out. So that whatever the weight of the stone it occupies here inside the displacement can, that amount of water will come out in the beaker. Okay. Now from here, what you will observe, what result you will get is that weight of the body in air. Weight of the body in air means you will find the weight of the stone in air. Let us consider as W1 gram force. Then again, the weight of the body in water. Weight of the body in water means weight of the body of stone in water, which is given in a by the mark in the spring balance. Okay, let us consider as W2. Then weight of the empty beaker. Empty beaker means the beaker. Okay, the beaker has been dry. Okay, first we find the weight of the empty beaker. Let us consider as M1 gram force. And beaker, weight of the beaker and the displaced water means the beaker as well as the water which has been displaced. Let us consider M2 gram force. Okay, weight of the beaker, dry beaker M1 gram force. Weight of the beaker as well. Now this beaker as well as the water contained in the beaker, which we call it as displaced water together, M2 gram force. Okay. Now apparent loss in weight of the body. So when the body is placed inside the fluid, what will happen in the liquid? There will be the apparent loss in weight. So apparent loss in weight, how we calculate? W1 minus W2. Okay, that means W1, why I am writing W1? Because the weight of the body in air is greater than the weight of the body in water. Because in water the weight of the body decreases, so the value becomes less. So I write it here W1 minus W2 gram force. Okay. Now again, weight of the displaced water. Displaced water means the water which has been displaced after putting the stone inside the water can be calculated as M2 minus M1. That is M2 minus M1. M2 minus M1 means beaker and the displaced water. This weight will be more than the weight of the empty beaker. So M2 minus M1. So finally, what result you will get is W1. That means W1 minus W2 equals to M2 minus M1. That means the apparent loss in weight. Okay, the loss in weight is equal to the weight of the displaced liquid, which verifies Archimedes' principle. So now this calculation, whatever this calculation I have done it here, this calculation is required when you solve the numericals. Okay, thank you.